Now if probability score is greater than 0.9, then we mark it as significant, that is 1. And if the probability score that we calculate is less than 0.1, then we mark it as -1 and 0 in other case. So we define a function for two sample t-test, that is, we name the function as stat comparison, then pass an argument. Now the argument here is city, because we want to compare whether one segment versus other segment, and this segment is nothing but determined in our case based on city, because we want to know whether one city booking in one city outperform the booking in the other city. And to check that, we do a two sample t-test to verify whether the outperformance is statistically significant, right? So we group by the user location city and is booking, and aggregate new attributes, that is sub average, which is nothing but the average, and sub bookings, which is nothing but the count. And then we derive these 4 different attributes and then use this attribute to calculate the z-score. So the z-score is calculated as the sub-average, difference of sub-average and rest average divided by the square root of overall average into 1 minus overall average into the sub bookings, 1 divided by sub bookings plus 1 divided by rest bookings. So this is the standard formula of z-score, wherein you take the mean and then the variance and the standard deviation of the sample, and then find the difference between the value in the sample and the mean and divide it by standard deviation. So that is what we do here, that is we take the difference between the value in the sample and the mean and divide it by the standard deviation. So once we calculate z-score, then we calculate the probability, and after we calculate the probability from the we use this stats package from SciPy, and then once the probability score is calculated, then we create a new variable to mark the significance, that is based on the condition that if probability score greater than 0.9, then we mark it as 1, and if probability score less than 0.1, then we mark it as -1, and other cases we mark it as 0. And then, so let me show you. So we compute this cell, then we call this function and pass the argument user location city. So you can see that for user location city, we calculated different attributes like sub bookings, sub average, overall bookings, and then calculate the Z scope, and then derive probability, and from probability we interpret the significance or significant, whether the result is significant. So you have the results of 2 sample t-tests. So from this you can understand that which user location city is underperforming and overperforming. We were answering the question that which segment of this hotel booking transaction data, which city is like profitable and which city was not profitable, so that the company can look into those segments and come up with some new campaigning strategies and so on. Our next objective is, once we know that which segment is underperforming and overperforming, then we need to focus on tailoring new marketing campaigns for different cities in the upcoming months. So to do that, we want to understand what cities we can focus. So the task here is, can we group all the similar cities together so that we can set some marketing strategies or campaigns for those similar cities, right? So for this particular objective, we will perform clustering. So to perform clustering, before that we have to see that what features are we going to use and which features make sense. So simply, what features may distinguish cities? So based on business sense and our exploratory data analysis, we know that the newly derived feature, that is duration, days in advance, the original destination city distance, then whether the booking is done from mobile or not, whether the user who has done booking has availed booking through package, what is the adult count, children count, room count. So based on the basic understanding of the business and the preliminary data analysis, we select the features. So we create a list, num list, and select the features. the most relevant important features, and then also take user's city location, because we want to group cities that are similar and have similarities, so that we can set up a campaigning strategy. So we group by user location city, take the mean and drop any null value, if any. Okay, so that is what is done in this step. So you can see city groups dot shape 4530, and the columns are the columns that we selected, and let's just peek into the data. Okay, so you have user location city, duration, days in advance. Okay, now before we proceed with clustering, we need to standardize the data, because this clustering algorithms, especially k-means, based on Euclidean distance, so the magnitude of the data range should be similar. So I make a copy of our group city, name it as city groups std, and then iterate through the list and use scikit-learn preprocessing to scale all the features. So we have the scaled data in city groups std. So you can see now the scale is uniform. So after we standardize the data, then we select clustering method and number of clusters. So for this, there are different various ways with which you can choose the appropriate number of cluster. Here I use the elbow method, so that this is very widely used method. So elbow method choose k, so that the sum of the square error of distances decreases drastically, and based on that it helps to derive the optimal number of k. So again use this scipy library, import cdist. Now here we do k-means cluster analysis for 1 to 10 clusters in random, because we don't know that which will be the appropriate cluster, number of cluster or size of the cluster to proceed with clustering for our data. So we put clusters range 1 to 11, that is 10 clusters, then create a list for storing the mean distance, then loop through each cluster and fit the model to the train set. So loop through each cluster and fit the k-means model to the training set, and compute the mean distance and append the information back to mean distance list.